Hello everyone, it's nice to meet you all. Welcome to my section of text representation. My name is Video1. I'm a second-year doctoral student at Carolina Health Informatics program in biomedical health informatics. My research interests are mainly in natural language processing, text summarization, and graph theory. So let's get started. Why do we need text representation at all? Well, to make a chunk of text written in natural language understood by machine, we have to do some transformations. All data inside a computer is transmitted as a series of electronic signals that are either on or off. Therefore, in order for a computer to be able to process any kind of data, including text, images, and sound, they must be converted into binary form. Here are some examples of the transformation between decimal and binary systems. For example, the first one shows the binary form for, we say, a string of zeros of the decimal number 0. And every decimal number can be transformed into their binary system if needed. Of course, according to a different encoding system. Encoding systems are ways to represent symbols, characters, and numbers by integers. ASCII key is one of example of an encoding system. Texts are stored as strings of zeros and ones in the computer, but before we go deeper, we need to choose the unit of our text to be represented. Sentences embed complex information but may not be a good choice. All sentences are almost unique, especially the long ones. There are a lot of variations of sentences, and it will be expensive to store all different sentences in a hard drive. So we want to chop the sentences into smaller pieces, but to what degree? Character sounds general enough, as there are only 26 of them in English. However, the semantic meaning and syntactic structure will be totally lost if we represent a sentence in characters. So what about words? Well, at level of complexity between sentences and characters, sound like a good solution. As words are the smallest semantic unit in human language, using words as the unit of text for representation preserves meanings while limiting the variation, which are unpredictable in sentences. The information embedded in syntactic structures might be lost in this phase, but you should be able to catch back a little bit by syntactic parsing and post-tagging, which we talked about in the previous section. Through the syntactic parsing and post-tagging, you should be able to mark the syntactic roles of the components of a sentence and use them as features in a machine learning model. You will learn more about applying these features in the later sections. This brings us to our first solution, representing a text into a bag of words. So what words are in our bag? Well, the words should be informative, which means we should remove duplicates and stop words. The stop words are important components of sentences, but useless by standing alone. It might not be intuitive to remove duplicates, since if a word appears multiple times, it should be important. We will take this into consideration when we move on and talk about term frequency later. The bag of words can be thought of as a vocabulary, the set of words we are working with. In our vocabulary, we have a set of distinct terms appearing in all of the documents. Then we can build a term document matrix based on our vocabulary. 1 means that the term is present in the document, while 0 means absent. By reading the matrix, you may have a general idea of what the documents are about and which of them are more similar to each other. The first 5 documents seem like they are talking about breast cancer, while the last 5 are talking about Alzheimer's disease. In a machine learning algorithm, these terms can be used as features for a computer to learn and make decisions. For example, in a classification task, we will teach the computer that the first 5 documents are talking about breast cancer, and then when the computer encounters a new document with a similar feature arrangement in the test set, it can hopefully classify the document into a group of breast cancer. So let's take a look at some of the questions.